Greetings of the day. I welcome you all to another lecture on dynamic voltage restorer. In our last lecture, we started discussions on DVR. We have studied the basic structure and operating principle of DVR. And we tried to solve one numerical problem where we took two types of, two different conditions. In one case, we had an RL type of load and we found that the injected voltage by DVR was in quadrature with the current, so that the reactive power only is required from the DVR to regulate the load voltage. Source voltage was assumed to be 1 per unit, and the objective was to make load voltage also equal to 1 per unit. What DVR did, it injected a voltage VF in series with the load, and it made load voltage also equal to 1.0 per unit, same as source voltage. Hence it caused voltage regulation. But the voltage injected by DVR was found in quadrature, that's at 90 degrees with respect to the current which was flowing through the injection transformer, or meaning that DVR requires only reactive power to be injected. DVR requires only reactive power to inject for voltage correction, for voltage regulation. In the second case, we assumed load to be purely resistive, and with the help of phasor diagrams, we found that in order to regulate the voltage for a purely resistive load, in addition to reactive power, a small amount of active power also has to be injected by DVR so that the voltage is regulated, so that load voltage is same as source voltage. Let us today discuss the general case. Today's class is extension of previous class. So we will take general case. General case means, for example, this is your source voltage Vs. Okay. This is feeder impedance with feeder resistance as Rs, feeder reactance as Jxs. This is voltage at point of common coupling, and this is your load. And of course, this is load. This terminal voltage is same as load voltage. Current is I. Load current is I. We have not connected a DVR as yet for voltage correction. So in this case, what is load voltage? VL. It is source voltage minus I into Zs, voltage drop. Or we can write load voltage is equal to source voltage minus I times Rs plus Jxs. Or load voltage is equal to source voltage minus resistive voltage drop I into Rs minus J I into Xs, reactive voltage drop. From this you can write source voltage is equal to load voltage plus resistive voltage drop plus reactive voltage drop. Okay, we can explain it with the help of phasor diagrams like this. Taking load voltage as reference, load voltage phasor as reference, this is load voltage phasor VL. Okay, let us suppose this is the load current I. It lags behind the load voltage by phi. Now what is load voltage equal to? It is source voltage minus I into Rs drop. So there will be, when current flows through this feeder, there is resistive voltage drop. And that I into Rs voltage drop is in phase with the current I. And since this is the current, so draw a vector which will represent this voltage drop I into Rs. And you can see this vector is parallel to the current vector because this voltage drop is in phase with the current that actually caused this voltage drop. Okay. And then in addition to I into Rs drop, there is reactive voltage drop also, because this current flows through the feeder reactance and it results in reactive voltage drop. And reactive voltage drop is at 90 degrees to current. So it will be like this. This is the reactive voltage drop, J I into Xs. Okay. So this will be your voltage drop I into Zs. I into Zs is IRs plus JIXs. So therefore, what is your source voltage? This is your source voltage Vs. So you can find source voltage is higher than load voltage. In fact, source voltage is load voltage plus this voltage drop across the feeder I into ZS. Okay, or source voltage is equal to load voltage plus I into RS drop plus Ji into XS drop. That's what I have written here. So therefore load voltage is less than source voltage. So because of this voltage drop across the feeder, load voltage is less than source voltage. Okay, now we can draw the same phasor diagram if you take source voltage as reference. Now this is source voltage I am taking as reference, Vs. Okay, now again current is this, current lags behind the voltage by certain angle phi. Here it is load angle, load phase angle, and here it is supply phase angle. Anyway, this is phi. Okay, so this is source voltage. Let me take slightly longer vector, longer phasor. This is source voltage vector Vs. Now what is source voltage equal to? That is equal to load voltage plus this drop plus this drop, or load voltage is equal to source voltage. This is your source voltage minus resistive voltage drop. Resistive voltage drop is in phase with the current. If this is current, so resistive voltage drop will be I into Rs. You can see this I into Rs is parallel to current vector because this voltage drop is in the resistance, and we know that voltage across a resistance is in phase with the current. And in addition to this resistive voltage drop, there is reactive voltage drop which is at 90 degrees to the current. So reactive voltage drop will be this. This is Ji into XS. You can see it is at 90 degrees to the current. So therefore, where is your load voltage? So this will be your load voltage VL. And phase angle between load voltage and source voltage is delta, which is called power angle. In this case also power angle is delta. Okay, now we can again see load voltage is less than source voltage. Load voltage is of course equal to source voltage minus I into Rs drop minus Ji into XS drop. Okay, so I hope that's clear. And in both the cases, whether you take load voltage phasor as a reference or source voltage phasor as a reference, you get same results. You find that load voltage is less than source voltage by I into Zs drop, voltage drop. That is I into Rs plus Jxs voltage drop. And another point which is very important is that the source voltage phasor leads the load voltage phasor by phase angle delta. In this case also, Vs source voltage phasor leads the load voltage phasor by delta, and delta is called power angle. Okay, and when source voltage leads the load voltage, that means the power is flowing from source to load. If reverse would have been case, that means if load voltage would have led the source voltage, then power would have flown from load to source. But in this case, we know that power has to always flow from source to load, because you have source, energy source on this source side, and load consumes the energy. So power has to flow from source to load. So that's why source voltage phasor leads the load voltage phasor by delta in both the cases. Now let us try to compensate for the voltage drop and try to regulate the load voltage using DVR. So when we use DVR, see what happens. I will write here voltage compensation using dynamic voltage restorer, DVR. Voltage compensation using DVR. Now what I will do, I will connect a DVR here. And so this is my DVR. This is your voltage at the point of common coupling. So ये आपका point of common coupling बन जाता है. And this is DVR injected voltage VF, और ये आपकी load voltage है VL. So between point of common coupling and load, that is between VT and VL, I have connected a DVR, and DVR acts as a voltage source. It injects voltage in series with the load. So what is the purpose of injecting this DVR voltage, compensation voltage? To regulate the load voltage, make load voltage same as source voltage. Now if you apply KVL in this circuit, you will get this Vs plus Vf is equal to, so I will show you again, start from here, minus to plus is Vs. This Vs is same as this Vs. So minus Vs, then plus I into Zs, okay, plus Vt, plus minus Vf, plus load voltage. See, load voltage is like this. It is same as this bus voltage, is equal to 0. So minus Vs plus this drop plus minus Vf plus VL is equal to 0 by application of KVL. Or if you take this Vs and Vf on one side, you can write Vs plus Vf is equal to Vs plus Vf is equal to, take these to other side, I into Zs plus VL. Okay, so from this we can write like this. So from this we can find Vs, source voltage. Source voltage is equal to VL, load voltage, plus I into, what is Zs? Zs is Rs plus JXS. This Vf I am shifting to other side, so it will be minus Vf. Or source voltage Vs is equal to VL plus I into Rs plus J I into XS minus Vf. So from this, source voltage Vs is equal to VL plus I into Rs minus Vf minus J I into XS. So now it's a very interesting equation. Without this DVR injected voltage, your source voltage just few moments back you have seen was equal to load voltage plus I into Rs plus J I into XS. Now with DVR, it gets modified. The equation becomes Vs is equal to VL plus IRS minus times Vf minus J I into XS. Okay. So what this Vf injected voltage tries to do? Actually, your source voltage is greater than load voltage by this drop and this drop. In between now, an additional voltage has arrived in the equation, that is this compensation voltage, DVR injected voltage. This injected voltage will subtract from these two drops. That means it will try to compensate these two drops. It will try to negate or cancel the effect of these two drops in such a way that source voltage becomes same as load voltage. Which means it will try to make I into Rs minus Vf minus Ji into XS equal to 0. So this is what DVR will do. DVR will do this. It will make this drop minus this equal to 0. See, there is already resistive voltage drop. There is already a reactive voltage drop. And then there is DVR injected voltage. Now this DVR injected voltage will try to nullify these two drops in such a way that this drop minus plus this drop minus this becomes equal to 0. So that means this resistive voltage drop from here plus reactive voltage drop minus this DVR injected voltage is equal to 0. That means DVR injected voltage will be equal and opposite to these two drops. It will be in such a way that it will make this DVR injected voltage will be equal and opposite to these two voltage drops. And when it is equal and opposite to these two voltage drops, the net voltage drop is 0, and that gives your load voltage same as source voltage. Load voltage equal to source voltage. Okay. From this equation, we can write load voltage equal to VL is equal to Vs minus I into Rs plus Vf minus Ji into XS. This is from this equation. जो equation मैंने ये लिखी है. This is Vs and VL will be source voltage minus this drop plus this. Okay. And again, I tell you that this drop plus this will be equal to 0. DVR will try to make this drop, resistive voltage drop plus reactive voltage drop, and plus this injected voltage, the phasor sum of the three equal to 0. And when this is equal to 0, so therefore what will be your load voltage? It will be same as source voltage. Now you will understand it with the help of a phasor diagram. Let me show you it in the form of a phasor diagram. Now in the phasor diagram, this is our load voltage. You can see, for example, this is my load voltage VL, and this is my load current I, and this is load power factor angle phi L. Now there is resistive voltage drop in the feeder, that is this I into RS, and there is reactive voltage drop in the feeder, that is this J I into XS, and your source voltage is this. This is your source voltage Vs. Now we can see source voltage leads the load voltage by power angle delta, that means power flows from source to load. Anyway, that is one aspect. Another aspect you can see from here, that source voltage is greater than load voltage by this drop plus this drop. Or in other words, load voltage is less than source voltage by this drop and this drop. So source voltage is load voltage plus IRS plus JIXS. In other words, load voltage VL is equal to source voltage minus this drop minus this drop. Now our aim is to make load voltage same as source voltage. How to do that? देखिए, अगर ये source voltage phasor है, see, this is your source voltage phasor. Right now it is here. After some time it will be here. After some, because it's a rotating phasor. So therefore इसकी trajectory क्या होगी? Source voltage की trajectory ये होगी, circle. So it will be rotating in the circle like this. It's a rotating phasor. All phasors, of course, here are rotating phasors. This is your source voltage phasor. It rotates in the counterclockwise direction like this, and when it rotates, it basically its trajectory is basically a circle. It rotates along a circular path, and that's called trajectory. Therefore, अगर आपकी source voltage ये है, this is the source voltage, इसकी trajectory क्या होगी? This will be its trajectory. Circle will be its trajectory. ये इसकी trajectory है. I will write here trajectory of source voltage, right? Now aim क्या है? Aim is that this load voltage should become equal to source voltage. तो इसका मतलब ये load voltage phasor यहाँ आना चाहिए. So this should be your load voltage. That means load voltage should be equal to source voltage, because when load voltage phasor, which was of this length, I have extended it, I have made it touch the trajectory of source voltage. So this load voltage becomes equal to source voltage. But in order for load voltage to become equal to source voltage, what is the equation? Let me write that equation again. Vs is equal to VL plus I into RS minus VF minus JI into XS. It has to satisfy this equation. In order to satisfy this equation, now if this is your load voltage, it is same as source voltage. Now there will be, because of the flow of current, there will be resistive voltage drop. Resistive voltage drop will be in phase with the current. Okay, what is resistive voltage drop? I into RS. ये I है आपकी. So this is resistive voltage drop. I into RS. अब आप फिर से देख सकते हैं, अगर आपकी सोर्स वोल्टेज ये है, तो आपकी if you make load voltage equal to source voltage, और ये आपकी resistive voltage drop है, तो आपका फेजर यहाँ आएगा, तो actual source voltage will be greater than load voltage, but we want that our load voltage should be same as source voltage, whose trajectory is this circular path. But what happens because of the resistive voltage drop, ये आपका drop आ जाता है I into RS, which is in parallel with the current phasor, because this voltage drop is in phase with the current. Okay, ये तो हो गया ये. So this is your VL plus I into RS. उसमें से subtract हो जाएगा ये minus VF minus JIXS in such a way that the sum of these two drops becomes equal to 0, and your source voltage, load voltage, is same as source voltage. Now if this is your I into RS drop, that is this drop, what is this? This is आपका DVR voltage inject कर रहा है, okay, और वो reactive drop में से subtract हो रहा है. So normally this reactive voltage drop, अभी थोड़ी देर पहले आपने देखा, ये ऊपर जाता है, because that reactive voltage drop is at 90 degrees to current. लेकिन यहाँ it is not only I into XS, it is VF minus I into XS. VF जो है, it is opposite this injected voltage if this is the inductive voltage drop, this injected voltage by DVR will be capacitive in nature. उसका मतलब ये हुआ अगर ये फेजर ऊपर की तरफ जा रहा है, ये VF नीचे की तरफ इसको लाएगा. So instead of going up, it will come down. ये आपका वेक्टर जो है, ये फेजर है जो नीचे की तरफ आ रहा है, it is I should say locus of this VF minus JI into XS. ये VF minus JI XS का locus है, ये नीचे जा रहा है. So when it goes down and it touches the trajectory, okay, and this ये trajectory क्या है आपकी? ये trajectory आपकी source voltage की है. Therefore आपकी source voltage अब ये बन जाएगी. ये आपकी source voltage बन जाएगी. So this will be your source voltage Vs. And you can now see that this source voltage is exactly equal to load voltage, or load voltage is exactly equal to source voltage. So what your DVR has done, in order to make load voltage equal to source voltage, actually your load voltage was less than source voltage, it was this. In order to make this load voltage equal to source voltage, it should touch the trajectory of source voltage. So when we have extended the length of this phasor, it has touched the trajectory of this source voltage. So load voltage has become equal to source voltage, but there is a resistive voltage drop. Okay, so if this is resistive voltage drop, the reactive voltage drop or the locus of this VF minus JIXS should be such that instead of going that drop up, वो drop नीचे आना चाहिए, वो इस drop को भी compensate करना चाहिए और reactive voltage drop को भी compensate करना चाहिए, so that IRS drop minus VF minus JIXS drop, ये सारा drop equal to 0 हो जाता है. जब ये दोनों drop मिलके 0 हो जाएंगे, I mean this minus this 0 हो जाएगा, so what will be your load voltage? Your source voltage will become same as load voltage, or in other words, load voltage will be same as source voltage. So that means ये phasor अब नीचे आएगा. So this is the locus of VF minus JIXS. So that means DVR injected voltage will oppose both the drops, resistive voltage drop and reactive voltage drop, in such a way that this becomes your source voltage. तो ये अगर आपकी source voltage है, because it is along the trajectory, ये आपकी load voltage है. In this way your load voltage becomes exactly equal to source voltage. लेकिन इस केस में एक चीज ये हो जाती है that source voltage is now lagging load voltage by say delta dash. I told you earlier that for making power to flow from one end to another end, if you want to make power to flow from source to load, source voltage should lead the load voltage. Okay, but here you can see source voltage in presence of DVR, it seems that source voltage lags load voltage. That means power source से load की तरफ flow नहीं हो रहा है, बल्कि load से source की तरफ flow हो रहा है. But that is not actually the case. Actually, even if you get phasor diagram like this, which shows that your source voltage lags the load voltage by delta dash or by delta, so that VL is equal to VS, load voltage is same as source voltage, so that load voltage regulation is done. It does not mean power flows from load to source. Power can never flow from load to source, because your load is passive element and source is active element, and power always flows from active element to passive element. Okay, so थोड़ी देर बाद मैं आपको समझाऊंगा. I will explain that. So therefore the generalized phasor diagram. Let me draw the generalized phasor diagram. Generalized phasor diagram of DVR compensated distribution system. Of DVR compensated distribution system. So this is your distribution system. Source, load, and this is feeder resistance. Okay, and this is voltage compensation done by DVR. Okay, so generalized phasor diagram will be something like this. Now this is my load voltage VL, and I want that my load voltage should be same as source voltage. So this load voltage should be equal to source voltage. So that means this phasor is load voltage phasor and it is source voltage phasor also. तो source voltage की trajectory फिर ये होगी circular trajectory. It will have circular trajectory like this. This is the trajectory of source voltage, and it is the trajectory of load voltage also, because you are making load voltage equal to source voltage with the help of DVR series compensation. So if this is your source voltage or load voltage, this will be current, load current. This will be load current I, and load current is lagging behind the voltage, load voltage, by phi L. Okay. Now, if resistance is not there, so what will be drop equal to? Your load voltage will be source voltage minus I into excess drop, or I into excess drop ये होगी आपकी, that will be at 90 degrees to this. ये अगर current है इसके 90 degrees होगी वो drop. So that will touch the circular trajectory somewhere here. Okay, when it touches the circular trajectory, say for example this is your point A, ये point B होगा या B1 इसे हम कहते हैं, and your source voltage will be this. This will be source voltage. This will be source voltage. If this is load voltage, this is source voltage. Okay, and this will not be J I into excess. This will be trajectory of, because you are again, I will again write Vs is equal to VL plus I into Rs plus Vf minus Ji into Xs. For Rs, that is feeder resistance, equal to 0. The source voltage will be equal to load voltage plus Rs is 0. So it will be V plus Vf minus Ji into Xs from this equation, because Is is equal to 0. तो ये अगर आपकी VL है, what is this? ये क्या है? This is locus of this. So I will write here locus of Vf minus Ji into Xs. ये इसका locus है. And you can see the DVR is injecting the voltage Vf, which nullifies this voltage drop. So this injected voltage is equal and opposite to this voltage, so that this minus this becomes equal to 0, and your source voltage becomes exactly equal to load voltage. You can see source voltage is exactly equal to load voltage. This is in absence of feeder resistance. But in presence of feeder resistance, your source voltage is load voltage plus resistive voltage drop plus this thing, Vf minus Ji into Xs. And now this whole drop, I into Rs plus Vf minus Ji into Xs, this should become equal to 0, so that your load voltage becomes equal to source voltage. So in presence of feeder resistance, अब आपकी resistive voltage drop भी यहाँ होगी. There will be resistive voltage drop which is in phase with the current that causes it. तो ये अगर आपकी I है, so this will be resistive voltage drop, I into Rs. तो ये आपकी I into Rs voltage drop है. Okay, इसको and if this is I into Rs, उसके बाद मैं ये दिखाऊंगा Vf minus Ji into Xs. Vf minus Ji into Xs नीचे ऐसे आएगा. That will be at 90 degrees to. See, here also you can see one very important thing, that the injected voltage Vf will be at 90 degrees to current. ये जो है ना, ये for example it is trajectory of Vf minus Ji into Xs. इसमें DVR injected voltage भी आ जाती है. So you can see DVR injected voltage is at 90 degrees to the current. ये अगर आपकी current है 90 degrees पे, so that DVR does not inject any real power. It injects only reactive power for voltage compensation. Similarly here be, if this is your I into Rs, the locus of Vf minus Ji into Xs ऐसे होगा at 90 degrees to the current. It will go down, down, down like this. So that it will intersect this trajectory. This is trajectory of Vs. ये इसको दो पॉइंट्स पे कट करता है. एक पॉइंट A पे, दिस इज पॉइंट A, और एक पॉइंट B पे. So that means when it is touching, so what is basically this? Let me write it again. It is locus of Vf minus Ji into Xs. ये इस चीज का locus है. It is reactive voltage drop minus DVR injected voltage, and it should be at 90 degrees to current. So DVR injected voltage, you can see it is at 90 degrees to current. so that it's the reactive power. DVR injects reactive power only. It does not inject active power. Okay. Now this locus of Vf minus Ji into xs touches the trajectory of Vs at 2 points A and B. So therefore, when it touches it at A, this will be your source voltage. This will be source voltage Vs. Because if this is your load voltage, this will be source voltage. And source voltage is same as load voltage. ये लोड वोल्टेज है एंड ये इसको इस ट्रेजेक्टरी को बी पे भी इंटरसेक्ट करता है. ओके, ये दिस लोकस ऑफ वी एफ माइनस जे आई इंटू एक्सेस बी पे भी. तो दूसरा सोल्यूशन आपका ये है. दैट मीन्स दिस इज ऑल्सो वी एस. सो यू कैन सी यू हैव टू सोल्यूशंस इन दिस केस, दिस सोल्यूशन एंड दिस सोल्यूशन. यहाँ पे भी वी एस इज इक्वल टू वी एल और इस पॉइंट पे भी वी एस इज सेम एज वी एल. राइट, ये तो हुआ दूसरा. तीसरा एक्सट्रीम केस है, इफ यूर DVR, if you are, see for example, if trajectory of, if the locus of Vf minus Ji axis, if it is like this, it will touch the trajectory of Vs only at one point. Let us call this point as A, B, let's call this point as D. We can call this point as point D. ये point D है. ठीक है. So we call this point as point D. So in this case, ये आपका resistive voltage drop है I into RS और ये locus of Vf minus Ji axis है and it touches the trajectory of Vs here. तो इस केस में आपकी source voltage ये होगी Vs. And again you can see source voltage is same as load voltage. और अगर आपकी resistive voltage drop इससे भी ज़्यादा हुई तो you will get this will be in that case locus of Vf minus Ji into xs. ये आपका resistive voltage drop होगा. ये मैं I will write here. This is I into Rs. ये सारा यहाँ से यहाँ तक. If this is resistive voltage drop I into Rs, what is this? This is locus of Vf minus Ji into xs because your Vs is equal to Vl plus Irs plus Vf minus Ji into xs. Irs आपका ये है और ये Vf minus Ji xs ये है. तो उस केस में it does not intersect the circular trajectory anywhere. That means your DVR now fails to regulate the load voltage. आपकी load voltage regulate ही नहीं होगी. In order to regulate the load voltage, make load voltage equal to source voltage, ये सारा I into Rs plus Vf minus Ji into xs 0 होना चाहिए. So that source voltage is exactly equal to load voltage और load voltage is exactly equal to source voltage. तो उसके लिए ये ज़रूरी है फेजर डायग्राम से कि ये जो लोकस जब आप ड्रॉ करते हैं, चाहे आप यहाँ लोकस ड्रॉ करते हैं Vf minus Ji एक्सेस का या यहाँ, it should touch the circular trajectory of Vs. और जिस पॉइंट पे ये टच करता है वही पॉइंट आपका Vs हो जाता है and Vs becomes exactly equal to Vl. लेकिन इस केस में I into Rs इतना ज़्यादा है कि ये जो locus of Vf minus Ji axis, it does not touch the circular trajectory anywhere. So therefore your DVR will fail to regulate the voltage. So therefore उसका मतलब ये हुआ, ये अगर C है, इस पॉइंट को मैं अगर C नाम दूं, यहाँ इस पॉइंट को C, so ये आपका D है. So C और D यहाँ से यहाँ तक है. This is the limit of resistive voltage drop. Resistive voltage drop अगर C और D CD के बराबर है या इससे कम, then the locus of Vf minus Ji axis will touch the circular trajectory and you will get the solution. Your DVR will be able to compensate the voltage drop and it will make load voltage equal to source voltage, exactly equal to source voltage. वो आप यहाँ भी देख सकते हैं. यहाँ पे resistive voltage drop is less than this CD. ये CD है, ये C है, ये D है, CD. It is less than CD and it gives two solutions. तो यहाँ पे भी और यहाँ पे आप इन दो solutions में कोई एक solution दे सकते हैं. और अगर यहाँ पे है, if your resistive voltage drop is this much, it's exactly equal to CD, so it still touches the circular trajectory but only at one point. So in this case also it regulates the voltage. But if I into Rs drop, आपका ये I into Rs drop है, I into Rs, अगर I into RS drop greater than CD है, it's greater than CD, then DVR will fail to regulate the voltage. It will fail to regulate the voltage. So therefore there will be three cases. I will write here case A, I into RS less than CD. वो ये है, ये आपका I into RS है, I into RS ये ड्रॉप है, ये देखिए यहाँ से यहाँ तक, और ये CD है, ये C है, ये D है. It is I into RS, यहाँ देख सकते हैं आप, it is less than CD. CD यहाँ से यहाँ तक है. Shall I write this CD clearly? ये है CD. अलग से लिखता हूँ CD. Now I into RS यहाँ पे आप देख सकते हैं, it is less than CD. So therefore you have two solutions, 1 and 2. A पे भी the locus of VF minus I Ji axis touches the circular trajectory at 2 points, at A and B. So you have two solutions. That is A and B. A पे भी your source voltage is equal to load voltage. B पे भी आप देख सकते हैं source voltage is equal to load voltage. That means load voltage is exactly equal to source voltage and voltage is regulated. अब आप इन दो सॉल्यूशंस में कौन सा सॉल्यूशन चूज करेंगे? आई विल सॉल्व वन न्यूमेरिकल प्रॉब्लम, वहां मैं आपको बताऊंगा कैसे चूज करना है. You have to choose one of the solutions in such a way that DVR rating should be less. DVR rating should be less. अगर आप ये solution choose करते हैं, यहाँ DVR कितनी वोल्टेज इंजेक्ट करता है? सिर्फ इतनी, and it regulates the voltage, makes VS equal to VL. So यहाँ पे DVR की इंजेक्टेड वोल्टेज कम है और करंट तो ये है, करंट इंटू वोल्टेज इज DVR KVA रेटिंग. लेकिन अगर आप ये सॉल्यूशन चूज करते हैं, यहाँ DVR इंजेक्टेड वोल्टेज बहुत ज्यादा है, ये भी यही सॉल्यूशन देता है, इट मेक्स VS इक्वल टू VL, इट रेगुलेट्स द लोड वोल्टेज, बट DVR हैज टू इंजेक्ट लार्ज compensation voltage, and this large voltage, what is DVR rating? It is VF into I. Since VF here is very large, so DVR की rating ज्यादा होगी. So therefore out of the two solutions we will always go for this solution, क्योंकि यहाँ पे DVR injected voltage is less और इसकी rating, power rating भी कम है. So this is case A. Let us quickly go to case B. Case B is I into RS equal to CD. This resistive voltage drop is exactly equal to CD. ये CD है और ये resistive voltage drop है. इस case में you have only one solution, because this is locus of VF minus Ji axis. It touches the circular trajectory only at one point. So where is the solution? Solution is at point D. Only one solution. Only one solution. And again, load voltage is exactly equal to source voltage. So this is the extreme case. Okay, when this resistive voltage, feeder की resistive voltage drop exactly CD के बराबर होगी. But if you go to case C, अगर resistive voltage drop feeder में CD से ज़्यादा होगी, if I into RS is greater than CD, like this, ये वाला case, ये I into RS है, ये I into RS है, you can see it is greater than CD. CD इतना ही है. In that case, even if your DVR injects the voltage and this is the locus of VF minus Ji axis, it does not touch the circular trajectory anywhere. So that means your DVR fails to regulate the voltage. So therefore load voltage will be less than source voltage. Okay, so your DVR will not be able. तो ये इसलिए है क्योंकि resistive voltage drop feeder की बहुत ज़्यादा है, and there may be two reasons for large resistive voltage drop across the feeder. One is कि feeder की resistance बहुत ज़्यादा है. Feeder is not properly designed. ये पतला कंडक्टर है और उसकी resistance ज़्यादा है, जो I into RS ज़्यादा देता है. दूसरा रीज़न ये हो सकता है कि लोड बहुत ज़्यादा है, लोड करंट हाई है. Load current is so high that I into RS is greater than CD, and your DVR fails to regulate the load voltage. So these could be the two reasons. So therefore, for regulating the load voltage, your I into RS should be either less than CD or it should be at the most equal to CD, but it should never be greater than CD. Okay. Now VL, I will write here VL is equal to VS is equal to V is equal to 1.0 per unit. This is the objective. We want to make load voltage equal to source voltage equal to V, that is same, let us say 1 per unit. ओके, सो ये डायग्राम मुझे फिर से ड्रॉ करनी पड़ी. आई एम सॉरी, आई शुड नॉट हैव, बट आई हैड नो स्पेस, आई हैड टू erase it. No problem, we can draw it again. Uh, this is ये I है आपकी I, and this is I into IL. This is say IRS और ये trajectory है इसकी. This is the locus of PF into IRS. So you have two solutions, A and B. And extreme case में ये solution आपका होगा. This is VS, or in this case this will be VS. Extreme case में ये होगा, ये solution होगा, ये I into RS होगा, and this is the locus. और आपकी source voltage ये होगी VS. Okay, let us call this point as, now मैंने पहले ही कहा ये C है, ये D है, तो इसका मतलब ये C है तो ये भी C है, ये D है तो ये पॉइंट भी D है. और ये एक और solution है, if I into RS is greater than CD, then no solution. Anyway, this is C, this is C, this is D, this is C, this is D. This is the resistive voltage drop. Resistive voltage drop can, this is I into RS. It can be either less than CD or it can be at the most equal to CD. It should not be greater than CD for voltage regulation, for perfect compensation by DVR. Now, अगर आपको ये CD निकालना है, फेजर CD, इसकी लेंथ निकालनी है. What is this CD equal to? ये आप देख सकते हैं, this CD is equal to OD minus OC. OD minus OC. Total OD में से OC निकाले, you will get CD. Okay. So what is OC? देखिए ये आपकी right angle triangle है. This is the right angle triangle. This is base. This is perpendicular. So OC by base, and this is hypotenuse. I'm sorry, base by hypotenuse VL is equal to cos phi L. ये phase angle phi L. This is perpendicular. This is base. This is hypotenuse. Base is OC, hypotenuse is this, and this is your load voltage आपकी. So OC by load voltage is cos into phi L. So that will give me OC equal to VL cos phi L, right? So therefore, what is CD? CD is equal to OD minus OC. अब OD क्या है? OD ये है. OD is equal to VS, isn't it? Equal to VS. OD is equal to VS, or it is equal to V. और VL भी आप लिख सकते हैं, because VL is equal to V. VL minus OC. OC ये भी आपने ऊपर निकाला, minus VL cos phi L. So that will give me CD equal to VL. अगर मैं बाहर निकालूँ, I will get 1 minus cos phi L. Since VL is equal to VS equal to V. Okay. So therefore CD is equal to, I can write V into 1 minus cos phi L. तो ये मुझे फिर यहाँ से फिर मैं एक कंडीशन निकाल सकता हूँ, एंड दैट कंडीशन इज दैट I into RS should be less than or equal to CD which should be less than or equal to V into 1 minus cos phi L. क्योंकि CD का वैल्यू क्या है in terms of voltage and in terms of load phase angle, load power factor angle. It is V into 1 minus load power factor. V, that is the load voltage, which is same as source voltage, into 1 minus load power factor cos phi L. So CD should be greater than or equal to I into RS. तो आपका voltage drop feeder में जो होता है resistive voltage, that should be either less than CD or that should be equal to CD. और ये CD in turn किसके बराबर है in terms of voltage and power factor? It is voltage, load voltage और source voltage multiplied by 1 minus load power factor. Okay? तो यहाँ से आप RS का लिमिटिंग वैल्यू निकाल सकते हैं. सो देयरफॉर फीडर की रेजिस्टेंस शुड बी लेस देन और इक्वल टू V टाइम्स 1 माइनस cos phi L by I. यहाँ से आप निकाल सकते हैं, बिकॉज दिस इज इक्वल टू दिस. और तो यहाँ से आपको पता चले व्हेन यू डिजाइन द फीडर की रेजिस्टेंस इस वैल्यू से कम होनी चाहिए. इफ यू नो व्हाट इज द लोड करंट, यू नो व्हाट इज द लोड वोल्टेज or source voltage, you know what is load power factor, the limiting value of feeder resistance should be this, such that your DVR can compensate the voltage. It can give you voltage regulation. और यहाँ से आप करंट भी निकाल सकते हो. करंट इज लेस देन और इक्वल टू V into 1 minus cos phi L by RS. यहाँ से आप करंट भी निकाल सकते हो. ओके, so let us take three different values of resistances. Let RS be equal to three different values मैं ले लूँगा. 0.04 per unit एक वैल्यू है, दूसरा वैल्यू है let us say 0.1 per unit, और तीसरा वैल्यू है फॉर एग्जांपल 0.4 per unit. मैं तीन डिफरेंट वैल्यू फीडर रेजिस्टेंस के ले रहा हूँ, राइट. सो देयरफॉर तीनों वैल्यूज के लिए therefore what is, and let load voltage be equal to same as source voltage, let it be 1.0 per unit. So therefore what should be I should be equal to V is 1 into 1 minus cos phi L by RS for this value 0.04. Another value of I should be 1 into 1 minus cos phi L by दूसरा वैल्यू क्या है RS का से 0.1, और तीसरा वैल्यू है 1 into 1 minus cos phi L by RS that is 0.4. तो यहाँ से मुझे तीन वैल्यूज करंट के मिलेंगे. So I should be either equal to 1 by 0.04 is 25. 25 times 1 minus cos phi L per unit. दूसरा वैल्यू करंट का मुझे यहाँ से मिलेगा 1 by 0.1 is 10. So 10 into 1 minus cos phi L per unit, और तीसरा वैल्यू मुझे यहाँ से मिलेगा 1 by 0.4 is 2.5. So I is equal to 2.5 times 1 minus cos phi L per unit. So that means the maximum current that should flow in the system for a given power factor angle or for a given load power factor, for which your DVR successfully gives the voltage regulation, compensates the voltage drops. You can calculate those currents. Okay, और वो मैं graphically दिखा, और वो currents change होंगी with load power factor angle. So I can show you the variation. Let us suppose load power factor angle is 0. This is x-axis में is load power factor angle, that is phi L in degrees. ये मैं डिग्रीज में ले रहा हूँ, और y एक्सिस पे मैं I ले लूँगा फीडर करंट और लोड करंट इन पर यूनिट, राइट. This is 0 degree. Let me take leading power factor angles 20 degrees, 40 degrees, 60 degrees. Similarly, minus 20 degrees, minus 40 degrees, minus 60 degrees, minus 80 degrees. और लोड करंट है से 0 per unit. This is 0 per unit, 2 per unit, 4, 6, 8, 10, 12, 14, 16, 18 and so on. So first graph I will get like this. This is the first graph that I will get. This is for RS, source resistance equal to feeder resistance equal to 0.0, highest value of 0.4 per unit. Let me first of all draw. Second is this. Second curve ये है. This is for RS equal to 0.1 per unit. और तीसरा ये है. This is for RS equal to 0.04 per unit. अगर आपकी फीडर की रेजिस्टेंस बहुत कम है, so you can depending upon the load power factor, the current, large current can flow in the system, and your DVR will successfully compensate the load voltage drops, and it will regulate the load voltage, because your I into RS will be less than or equal to CD, which is the limiting case. But as your feeder resistance increases, say from 0.04 to 0.1, the current should be less. the less current should flow through the feeder. The load should draw less current, so that this condition is met and DVR compensates. And if your load feeder resistance is highest, say 0.4 per unit, it's a very large value, then a very small current should be drawn by the load for fulfilling this condition, that is I into RS less than or equal to CD, so that your DVR successfully compensates the load this voltage drops and regulates the load voltage. Okay. Now the question is how to calculate, how to compute the DVR voltage. Computation of DVR injected voltage. This is our next task. Having understood that how DVR compensates the voltage drops, how it regulates the load voltage, okay, and what is the maximum limit, or what are the limiting factors for successful compensation of successful voltage compensation by DVR. Having understood that, let us now try to develop a mathematical formula, or mathematical, we'll try to compute mathematically how much voltage a DVR should inject for voltage regulation. For that purpose, we know that this we will use same equation, Vs plus Vf is equal to VL plus I into Rs plus Jxs. Let us call this equation as equation 1. Okay. And now let VL be equal to same as Vs. Let VL be equal to same as Vs equal to 1.0 per unit. This is desired. We want load voltage equal to source voltage 1 per unit. That is, voltage compensation should be done by the DVR. And let us give this I into Rs. This I into Rs plus Jxs, this voltage drop, let us write it equal to A2 plus JB2. I mean, it has a real part, a reactive part. If you know current, if you know feeder resistance, feeder reactance, substitute here, you will get a real part and a reactive part. Let this be real part and this be reactive part. And let Vf, that is injected voltage, be equal to voltage injected by DVR compensation voltage or injection voltage. Let it be Vf at an angle of Vf, or it will be let us write it is equal to Vf A1 plus JB1. See, it is the injected voltage will be at some angle, phase angle. वो phase angle जब आप निकालोगे, you will get a real part and you will get a reactive part. So therefore we can substitute these values in equation 1. So therefore from equation 1 we can write Vs is equal to VL plus I into Rs plus Jxs minus Vf. Okay, so Vs is equal to VL plus, what is I into Rs plus Jxs? It is A2 plus JB2 minus Vf. What is Vf equal to? It is Vf into A1 plus JB1. Okay. So now our source voltage Vs is equal to Vs at an angle of delta. And Vs is same as load voltage. It is 1.0 at an angle of delta. So what does angle delta mean? It means cos delta plus J sin delta. 1 into cos delta plus J sin delta. Substituting in this equation. So therefore Vs is now cos delta plus J sin delta is equal to VL plus A2 plus JB2 minus A1 Vf minus JB1 Vf. Okay, I am expanding it. So further simplification will give me let me concentrate on this. It is VL and VL is 1. I'm sorry, VL is 1 because we have assumed VL equal to same as source voltage 1 per unit. So it is 1.0 or 1. So it will be 1 plus A2, 1 plus wait for a moment. Yeah, 1 plus A2, this is real part, this is real part. और कहाँ है real part? ये है real part. Minus A1 VF. ओके, इसको अलग रखते हैं, इसको अलग रखते हैं. उसके बाद reactive part, I will take reactive part. Plus, where is the reactive part? This is reactive part. Plus J times B2 प्लस और कोई रिएक्टिव पार्ट है, हाँ ये माइनस B1 VF, ओके, माइनस B1 VF. उसके बाद +1 है, ओके, हाँ वो 1 तो ऑलरेडी मैंने लिखा है. उसके बाद है माइनस, ये मैं यहाँ लाऊंगा cos डेल्टा, राइट हैंड साइड शिफ्ट करूंगा, cos डेल्टा प्लस J sin delta is equal to 0. Now what I will do, I will square each real component and real part and reactive part of the equation. So squaring real and reactive components. So real part is this, I will square it. So 1 plus A2 minus A1 VF whole square plus reactive part is this, I will square it also. So B2 minus B1 VF whole square minus इसका real part ये है cos delta whole square plus reactive part ये है sin delta whole square is equal to 0. अब इसको expand कर दीजिए. Okay, this is A और ये B है. This is A minus B whole square. Similarly, this is A, this is B. What is A minus B whole square? A square minus B square, A square plus B square minus 2AB. So that is equal to A square है आपका 1 plus A2 whole square plus B square B. A1 VF minus 2AB. 2 into 1 plus A2 into A1 VF. Okay? उसके बाद हम ये expand करेंगे. A minus B whole square, that is A square, that is B2 square, plus B square, that is B1 VF square, minus 2AB. A है B2 और B है B1 VF. Minus, this is cos square delta plus sin square delta is equal to 0. अच्छा, अब ये आएगा 1 plus A2 whole square plus this is A1 square VF square. ये टर्म भी मैं यहाँ लाऊंगा, ये इसके पास लाऊंगा प्लस B1 square VF square. ओके, माइनस ये टर्म 2 into A1 VF into 1 plus A2. ओके, ये हो गया, this is done, plus B2 square minus 2B1 B2 VF minus, what is cos square theta plus sin square theta? That is 1. So minus 1 equal to 0. So further simplification will give, let me take VF square out. So I will get VF square. What is inside? A1 square plus B1 square. A1 square plus B1 square. Okay, ये तो ये हो गया. माइनस 2 मैं बाहर निकालता हूं और ये तो VF स्क्वायर टर्म्स होगी. अब VF टर्म ये है और ये है, इन दोनों में से 2 मैं बाहर निकालता हूं. व्हाट आई गेट इनसाइड इज 1 plus A2 into A1. 1 plus A2 into A1. ओके, वो तो हो गया इसमें से, और इसमें से VF जब मैंने बाहर निकाला प्लस B1 B2 आएगा. Because 2 is also out, minus 2 I have taken out, so plus B1 B2 into VF, of course VF. उसके बाद मेरी constant terms है, like ये constant term है, plus 1 plus A2 whole square, उसके बाद plus B square minus 1 equal to 0. And by the way, what is A1 square plus B1 square? A1 square plus B1 square is equal to 1. You can see मैंने start में ही A1 और B1 define किया. A1 square plus B1 square is equal to 1. Okay, वो यहाँ substitute कर लीजिए. So therefore you will get final equation as this. Vf square, A1 square plus B1 square is 1. So Vf square minus 2 into 1 plus A2 into A1 plus B1 B2 into Vf plus 1 plus A2 whole square plus B square minus 1 equal to 0. This is a very important equation. This is a quadratic equation, and from this quadratic equation you solve for Vf and you will get two solutions for Vf. Two solutions for Vf. जो अभी थोड़ी देर पहले हमने जनरलाइज फेजर डायग्राम ड्रॉ की थी, उसमें वो टू सॉल्यूशंस हैं. ये पॉइंट्स A and B when I into Rs is less than CD. आपके दो सॉल्यूशंस मिलेंगे. For your reference, if I draw that again, phasor diagram again for your reference. वो ये सॉल्यूशंस हैं, I Rs है, I into Rs. This is the trajectory of Vf minus JIXS. ये दो solution, it touches the trajectory, and this is the locus of Vf minus JIXS. It touches the trajectory of Vs here. तो ये एक solution है point A, और ये यहाँ भी intersect है करता है, ये दूसरा solution है. ये अगर current I load current है, this is phi, तो दो solutions ये हैं. So this will be Vs और यहाँ भी Vs आएगा. Okay, so when you solve this quadratic equation, you will get two solutions, और वो points A and B है. ये point A, point B. Okay, let us try to solve one simple numerical problem, and that will make things very clear to us. This is the problem. The problem says, this is the example or numerical problem. It says consider a consider a system with a supply voltage V equal to 1.0 per unit at 50 Hz as shown in the following figure. यह है आपका system. Let me draw the system first. ये Vs है source voltage. This is feeder resistance and reactance Rs JXS. तो total impedance है Zs. Load current है I. Vt है आपकी point of common coupling पे voltage, और ये injected voltage है by DVR. DVR injected or compensation voltage, and this is load voltage VL, और ये आपका load है ZL JXL. Load impedance is, it is RL JXL. Total impedance is ZL. This is the system. Consider a system with a supply voltage V equal to 1.0 per unit at 50 Hz as shown in the following figure. This is the figure. This is DVR compensated distribution system. Consider the feeder impedance Zs equal to 0.05 plus J 0.3 per unit, and load impedance as ZL equal to 0.5 plus J 0.3 per unit. Part A, compute the load voltage without DVR. Part B, compute the current and DVR voltage such that load voltage is same as source voltage. That's voltage regulation is done. Part C, compute the effective source voltage including DVR. Explain the power flow in the circuit. And part D, compute the terminal voltage with DVR compensation. Let me write first of all source impedance. It is given, this feeder impedance is given Zs equal to Rs plus JXS, and it is given in the problem as 0.05 plus J 0.3 per unit. इसमें resistive part है 0.05 per unit and reactive part is J 0.3 per unit. And load impedance is also given ZL equal to RL plus JXL. Load resistance is 0.5 per unit plus load reactance is J 0.3 per unit. So total load impedance is 0.5 plus J 0.3 per unit. Part A, let us try to solve it. Solution. पार्ट ए में आपको निकालना है लोड, कैलकुलेट द लोड वोल्टेज विदाउट DVR. So I will write here without DVR compensation. DVR is not connected in the circuit in the system, so you have to calculate load voltage. ये load voltage है आपकी VL, voltage across the load, and it is equal to, what is load voltage by the way equal to? It is equal to load current, that's I into load impedance. तो सबसे पहले आपको load current निकालनी है. So therefore load current is same as source current, and let us denote it by I. And what is that equal to? That is load voltage, that is equal to source voltage divided by total impedance. देखिए source voltage है ये Vs divided by how much current is flowing in the circuit without DVR. Let me remove the DVR. DVR is not connected right now. So current in the circuit is the source voltage divided by this impedance plus this impedance divided by source impedance plus load impedance. So divided by source impedance Zs plus load impedance Zl. And what is in the problem? It is said that source voltage you have to take as 1.0 at an angle of 0 degree per unit. You have to take it as reference. So source voltage is 1.0 at an angle of 0 degree divided by how much is source impedance? It is 0.05 plus j 0.3 plus what is load impedance? It is given in the problem as 0.5 plus j 0.3. So therefore I is equal to 1 divided by 0.05 plus 0.5 is 0.55 plus j 0.3 plus 0.3 is 0.6. ये जब आप calculate करेंगे, I have calculated it in rectangular form, it will come out to be 0.83 minus j 0.91 per unit. And when you transform it into polar form, current will come out to be 1.2286 at an angle of minus 47.49 degree per unit. तो ये करंट है जो सिस्टम में फ्लो हो रही है विदाउट DVR compensation. तो इस करंट की ये करंट जब when this current flows through the load impedance, it will cause the voltage across the load, और वो load voltage आपको निकालनी है. So therefore what is load voltage? Load voltage is current into load impedance. Okay, and load voltage is equal to current कितनी flow हो रही है ये, it is 1 point, let me write it here. So load voltage is equal to current, which is 1.2286 at an angle of minus 47.49 degrees into load impedance. और load impedance आपकी कितनी है? It is given here 0.5 plus j 0.3. Now this is in polar form, this is in rectangular form. You convert this also into rectangular form, multiply that with this, you will get load voltage. And as per my calculation, I have calculated load voltage. I have got a load voltage without compensation equal to 0.7164 at an angle of minus 16.53 degree per unit. This is the load voltage. So therefore आपकी source voltage कितनी है? 1.0 at an angle of 0 degree per unit. लेकिन आपकी load voltage source voltage के बराबर नहीं है. It is only 71.64% of source voltage. So I can say that load voltage is 71% of rated value. Therefore load voltage is approximately 71% of rated value. I mean, your load voltage should be same as source voltage for zero voltage regulation, but it is source voltage is 1 per unit, load voltage is only approximately 0.7 per unit. That means load voltage is approximately 71% of rated value. So about 29% of voltage is missing. To make load voltage same as source voltage, 29% of load voltage is missing there. Okay, so this is part A. What else we have to calculate? In part B, we have to calculate, it's written here, compute the current and DVR voltage such that VL is equal to Vs. Now you have to go for DVR compensation, part B, with DVR compensation. You have to connect now DVR. Let me connect DVR. This is the DVR injected voltage, VF. DVR is doing the compensation now. With DVR compensation, you have to calculate the new value of current. Okay, so what is objective? Desired objective is to make load voltage same as source voltage, that is 1.0 at an angle of 0 degree per unit. 1 per unit hona chahiye, because your source voltage is also 1 per unit. Okay, so therefore VL is 1 per unit. So therefore अगर आपका VL 1 per unit है, 1.0 at an angle of 0 degree per unit है, in presence of DVR injects the missing voltage, so that load voltage is same as source voltage, that's 1.0 at an angle of 0 degree per unit. Therefore current कितनी होगी? How much will be the current? Therefore current, load current I will be equal to VL by ZL. VL after compensation is 1. So 1.0 at an angle of 0 degree by impedance कितनी है आपकी? Load impedance, it's given here 0.5 plus J 0.3. ये आप निकाल लिए. So current comes out to be, new value of current comes out to be 1.47 minus J 0.88 per unit in rectangular form, and in polar form it is 1.715 at an angle of minus 30.96 degree per unit. ये है current. Without DVR compensation, just few moments back we calculated the current. Load current was 1.2286 at an angle of minus 47.49 degrees per unit, and with load this DVR compensation, it increases from 1.2286 to 1.715 at an angle of minus 30.96 degree per unit. So load current has increased. After this, what else we have to find? And we have to find DVR injected voltage. उसके लिए अभी थोड़ी देर पहले हमने एक formula derive की थी. What was the formula? DVR voltage calculate करने के लिए the formula was VF square. Let me write that, minus 2 times 1 plus A2 into A1 plus B1 into B2 VF into VF plus 1 plus A2 whole square plus B2 square minus 1 equal to 0. तो इसमें अब आपको A1 का वैल्यू चाहिए, A2 का वैल्यू चाहिए, B1, B2. If you know those values, substitute. This is the quadratic equation. Solve the quadratic equation. You will get two values of injected voltage, and out of those two values, you have to select one value. And now, it's very interesting now as far as DVR injected voltage is concerned. अभी मैंने आपको कहा DVR injected voltage हम इस तरह लिखते हैं, VF A1 plus JB1. Okay, और हमने ये लिखा था VF at an angle of some VF. I told you that when DVR is used for voltage compensation, it injects the current, it injects the voltage in series with the load, so that load voltage is compensated. Load voltage is same as source voltage, in this case 1 per unit. And that injected voltage, you have seen from phasor diagrams also a few moments back, that injected voltage is in quadrature with the current. That means अगर आपकी load current ये है, injected voltage ये होगी, DVR injected voltage 90 degrees पे होगी, so that DVR does not supply real power, it supplies the reactive power only, because DVR क्या power supply करता है? VFI. And since DVR injected voltage and current, they are at 90 degrees, so that means it is supplying the reactive power only. और reactive power supply करने का मतलब हुआ, it does not need any energy store, it does not need any energy source at its DC bus. ये आपका DVR है, it has AC, जहाँ पे ये voltage inject करता है, and it has DC. DC पे capacitor से काम चलेगा. This is VDC, CDC. And when DC bus has capacitor, it will inject the reactive power and compensate for the voltage. लेकिन अगर इसको real power supply करना हो तो capacitor energy storage से काम नहीं चलेगा, then there should be some energy source like battery. But when you use DVR for voltage compensation purpose, you have to design the DVR in such a way that it injects the voltage in quadrature with the current, so that it has to supply only reactive power and not real power, and so that only at its DC bus at the DC bus of the DVR, which is basically a voltage source inverter, you connect an energy storage like capacitor, not energy source, not battery, not superconductor, not any other source of energy. You need energy storage only, that's capacitor only. That's possible only if it does not need to supply real power, if it needs to supply only reactive power. So therefore this angle, जो DVR का एंगल है, ये होना चाहिए VF करंट का एंगल, जो करंट का एंगल है प्लस 90 डिग्री। देखिए आप करंट रेफरेंस नहीं लेते, अगर करंट रेफरेंस लेते तो तब मैं कहता है कि DVR का एंगल 90 डिग्रीज हम लेंगे, लेकिन आपकी करंट कुछ इस तरह है, तो this is your load voltage, your current is like this, so therefore DVR जो वोल्टेज इंजेक्ट करता है VF, उसका एंगल क्या होगा, उसका एंगल होगा करंट का एंगल प्लस 90 डिग्रीज, ओके, बिकॉज करंट इज नॉट टेकन एज रेफरेंस, करंट इज एट सम फेज एंगल से फाई, तो देयरफॉर DVR की इंजेक्टेड वोल्टेज का एंगल होगा करंट का एंगल, दिस इज द एंगल ऑफ करंट से phi L plus 90 degrees, and when it is phi L plus 90 degrees, so that means DVR injected voltage, DVR injects reactive power only. So therefore I can write VF equal to VF, अभी थोड़ी देर पहले आपने करंट का मैग्नीट्यूड निकाला था, लेट मी राइट दैट अगेन। जब DVR हमने कनेक्ट किया था तो करंट का ये वैल्यू, करंट इन द लोड, this was the value 1.715 at an angle of minus 30.96 degree per unit. That means ये करंट लैग कर रही थी टू वोल्टेज बाय minus 30.96 डिग्री। therefore DVR का एंगल कितना होगा, DVR जो वोल्टेज इंजेक्ट करेगा उसका एंगल कितना होगा, उसका एंगल होगा करंट का एंगल, that is minus 30.96 degrees plus 90 degrees, so that the DVR injected voltage is in quadrature with the current and DVR supplies only the reactive power. So that is equal to VF. What is 90 minus 30.96? You can calculate it. 90 minus 30.96 is 59. Angle है 59.04 degrees. This is the angle. This is the angle. So VF is equal to VF at an angle of 59.04 degrees. Okay. Now, what does angle 59.04 degrees mean? It means cos 59.04 degrees plus J. So that is equal to VF into cos of 59.04 degrees plus J sine of 59.04 degrees. This is what we mean by angle at an angle of 59.04 degrees. So therefore, DVR injected voltage will be VF cos 59.04 degrees. I have calculated it is 0.51 plus sine 59.04 degrees is J 0.86. So that is equal to VF into A1 plus JB1. VF A1 plus JB1. तो ये A1 है, ये B1 है. This is A1 and this is JB1. So therefore what is A1? A1 is equal to 0.51 and per unit of course. And what is B1? B1 ये है 0.86. तो A1 और B1 निकल गया. उसके बाद हमें A2 और B2 निकालना है. A2 और B2 भी निकलेगा because when we solved this, when we were computing the DVR injected voltage, compensation voltage, we assumed that I into RS plus JXS is equal to A2 plus JB2. Okay, ये हमने assume किया था, it is equal to this. Now what is I? I आपकी कितनी है? I है आपकी, अभी थोड़ी देर पहले आपने लिखा, करंट है 1.46 माइनस J 0.86. करंट का वैल्यू, फेजर वैल्यू है 1.715 एट एन एंगल ऑफ माइनस 30.96 डिग्री पर यूनिट पोलर में. जब आप उसको रेक्टेंगुलर कोऑर्डिनेट्स में ट्रांसफॉर्म करोगे, करंट इज, आई विल राइट अगेन, दैट इज इक्वल टू 1.715 एट एन एंगल ऑफ माइनस 30.96 degrees. ये पोलर फॉर्म में पर यूनिट, रेक्टेंगुलर फॉर्म में ये 1.46 माइनस जे 0.86 पर यूनिट बन जाती है. दैट्स व्हाट आई एम राइटिंग हियर. वही मैं यहाँ लिख रहा हूँ. आई एम राइटिंग सेम थिंग हियर. 1.46 minus j 0.86 into RS plus JXS. RS plus JXS is feeder resistance and feeder reactance. It is given in the problem itself. अगर आपको याद हो थोड़ी देर पहले मैंने लिखा था feeder resistance is 0.05 plus J feeder reactance is 0.3 per unit. Okay, so if you solve this, this comes out to be 0.3041. इसको सॉल्व कर लीजिए. ये बनेगा 1.715 एट एन एंगल ऑफ माइनस 30.96 डिग्रीज. ये तो है ही. मल्टीप्लाइड बाई दिस, ये पोलर कोऑर्डिनेट्स में 0.3041 एट एन एंगल ऑफ 80.54 डिग्रीज. इन दोनों को मल्टीप्लाई कर लीजिए. सो यू विल गेट दिस एज इक्वल टू 0.5199 at an angle of 49.58 degrees per unit. ये पोलर फॉर्म है. रेक्टेंगुलर फॉर्म में ये बनेगा 0.3370 plus j 0.3958 per unit. And this is equal to A2 plus JB2 जो मैंने ऊपर लिखा. So therefore what is A2? A2 is this 0.3370 and B2 is reactive part of this 0.3958. That's all. Your job is done. You have got A1, you have got A2. थोड़ी देर पहले आपने A1 निकाला. A1 कितना था? A1 was 0.51 and B1 was 0.86. This is A1, this is B1, this is A2, this is B2. Substitute in this. Solve. So therefore VF square minus 2 into 1 plus A2. A2 है 0.3370 into A1 which is 0.51 here plus B1 B2. B1 है आपका 0.86 into B2 ये है 0.3958 to BF plus 1 plus A2 whole square 1 plus 0.3370 whole square plus B2 square. B2 है 0.3958 whole square minus 1 equal to 0. इसको solve कर लीजिए, simplify कर लीजिए. Take your calculator in your hand, solve this, you will get this equation for VF. VF की ये equation, quadratic equation ये आपको मिलेगी. VF square minus 2.0463 VF plus 0.9442 equal to 0. After solving this, after computing this. Okay, तो ये आपकी quadratic equation बन गई. So what is VF? Minus, that is 2.0463 plus minus under root of B square. B ये है 2.0463 square minus 4 into A into C 0.9442 whole divided by 2A. 2 into A is 1. Okay, इसको solve कर लीजिए. The solution of quadratic equation gives you two values of VF. You get VF equal to 0.7028 and 1.3434 per unit. ये point A है फेजर डायग्राम में भी, ये point B. अब आपको इन दोनों में से एक वैल्यू चूज करना है. जैसे आपको फेजर डायग्राम में पता है दो वैल्यूज आपको मिलते थे फेजर डायग्राम में. एक ये वैल्यू था A, एक ये. तो A is this. A point पे your DVR has to inject a voltage of 0.7028 per unit and it will make source voltage exactly equal to load voltage. It will regulate the load voltage. और अगर दूसरा solution आप लेंगे B पे भी source voltage is equal to load voltage or load voltage becomes equal to source voltage, but your DVR has to inject a larger voltage, almost double of this, 1.3434 per unit. So therefore the rating of the DVR for this value will increase. So therefore we will choose the smaller value for lower rating of the DVR. Therefore for smaller rating and less cost जब रेटिंग कम होगी तो कॉस्ट भी कम होगा of DVR. So what should be injected voltage? We take smaller value 0.7028 per unit. और अगर आप इसका एंगल भी लिखें तो दिस इज यू आर सपोज टू फाइंड दिस, सो VF आपका आता है ये वैल्यू 0.7028 एट एन एंगल ऑफ, एंगल कितना था 59.04 डिग्री पर यूनिट। तो ये VF आता है और वो रेक्टेंगुलर, ये तो पोलर फॉर्म में, रेक्टेंगुलर फॉर्म में है 0.3164 प्लस J 0.6028 पर यूनिट। ये पोलर फॉर्म, रेक्टेंगुलर फॉर्म में है और ये पोलर फॉर्म है। दिस इज व्हाट यू आर सपोज टू फाइंड इन पार्ट बी। कंप्यूट द करंट एंड DVR वोल्टेज सो दैट VL इज इक्वल टू VS, ये हो गया। और पार्ट सी में कंप्यूट द इफेक्टिव सोर्स वोल्टेज इंक्लूडिंग DVR, explain the power flow in the circuit. Let me take another pen. Excuse me. In part C, you have to find the DVR voltage. No, not DVR voltage. DVR voltage you have already found. You have to find the effective source voltage and you have to explain the power flow. That is part C. Let us go to part C. In part C, you have to find the source voltage. Now, what is your source voltage? Source voltage is given by, see, your VS plus VF, you already know, is equal to VL plus I into RS plus J XS. यहाँ से आप source voltage निकाल सकते हो. Source voltage is load voltage minus VF minus plus I into RS plus JXS. Okay, substitute कर लीजिए. Your source voltage is load voltage. DVR ने load voltage source voltage के बराबर बना दी और 1.0 at an angle of 0 degree minus VF. VF अभी थोड़ी देर पहले आपने निकाला, माइनस VF कितना है 0 point minus VF is the compensator voltage or DVR injected voltage 0.7028 at an angle of 59.04 degrees. Okay, plus I current कितनी है आपकी 1.715 at an angle of minus 30.96 degrees into RS है feeder resistance 0.05 plus J axis J into 0.3. ये निकाल लीजिए, यहाँ से आपको सोर्स वोल्टेज मिलेगी, दैट विल बी 0.9767 माइनस J 0.2056 पर यूनिट। ये तो रेक्टेंगुलर फॉर्म में, और पोलर फॉर्म में ये 1 के बराबर ही आएगी, लेकिन इसका एंगल आएगा -11.89 डिग्री पर यूनिट। दिस इज सोर्स वोल्टेज। अब यहाँ प्रॉब्लम ये है, सोर्स लोड वोल्टेज, your DVR has corrected your load voltage. It has made load voltage exactly equal to source voltage. That means if your load voltage was 1 per unit, your source voltage is also 1 per unit. So it regulates the load voltage. It does the voltage compensation. But problem is that source voltage should have led the load voltage by certain angle. But here source voltage is lagging the load voltage. ये मैं phasor diagram फिर से draw करूँगा आपकी reference के लिए. This was VL और this was I, this was phi L, ये आपका ये था IRS, ये JIXS था, and this was your source voltage VS. और I am falling short of space here. चलिए यहाँ मैं ड्रॉ करता हूँ. यह आपकी लोड वोल्टेज है VL which is 1 per unit. ओके, ये आपका I into RS ड्रॉप है और ये लोकस है. दिस इज द लोकस ऑफ VF माइनस, दिस इज लोकस ऑफ VF माइनस JI into XS. ये उसका लोकस है. एडिट touches your trajectory, this is the trajectory of Vs, ट्रेजेक्ट्री ऑफ वीएस, ये इसको 2 पॉइंट्स पे, तो आपके 2 सॉल्यूशंस आते हैं, ये, और हमने ये सॉल्यूशन ले लिया थोड़ी देर पहले। तो ये अगर आपकी वीएल है, व्हाट इज दिस वीएस, सो वीएस इज एग्जैक्टली इक्वल टू वीएल, वीएल भी आपकी 1 पर यूनिट थी, वीएस भी पर यूनिट, लेकिन प्रॉब्लम यहाँ ये हो गई कि वीएस इज लैगिंग बिहाइंड वीएल। ओके, तो ये योर सर्किट इज एक्चुअली दिस इज वीएस, this is feeder impedance RS, J access, this is current, ये VT है, ये यहाँ पे DVR इंजेक्टेड वोल्टेज है, ये लोड वोल्टेज है VL, और ये आपका लोड है RL, J XL, राइट। यहाँ पे प्रॉब्लम, इन ऑर्डर टू मेक पावर टू फ्लो फ्रॉम सोर्स टू लोड, सोर्स वोल्टेज शुड लीड द लोड वोल्टेज, दैट इज द पावर एंगल शुड बी पॉजिटिव, डेल्टा शुड बी पॉजिटिव। पॉजिटिव पावर एंगल का मतलब हुआ Vs, दैट इज सोर्स वोल्टेज फेजर, शुड लीड लोड वोल्टेज फेजर, लेकिन यहां सोर्स वोल्टेज फेजर लैग कर रहा है। जब सोर्स वोल्टेज, उसका मतलब डेल्टा आपका नेगेटिव आ रहा है, एज यू कैन सी नेगेटिव, नेगेटिव का मतलब है पावर अपोजिट डायरेक्शन में फ्लो हो रहा है। सो ये हमारी बेसिक थ्योरी ही वायलेट कर रहा है। पावर कैन नॉट फ्लो फ्रॉम लोड टू सोर्स, पावर हैज टू ऑलवेज फ्लो फ्रॉम सोर्स टू लोड, बट you have to understand now that this is the source voltage, and effective source voltage after compensation is this source voltage plus Vf. Now your load voltage is not getting this source voltage, it is getting this source voltage plus compensation voltage. Therefore load की effective voltage ये नहीं है, load की effective voltage कुछ और है. So therefore effective source voltage is not this. Effective source voltage is this plus compensation voltage. Let us call this that Vs dash. So that is equal to Vs plus Vf. This is effective source voltage. That is Vs. अगर compensation नहीं होती तो आपकी source voltage Vs ही रहती, लेकिन after compensation आपकी effective source voltage Vs plus Vf बन जाती है. Okay, and Vs dash is equal to Vs अभी थोड़ी देर पहले आपने निकाला 1 at an angle of -11.89 degrees per unit, और वो रेक्टेंगुलर कोऑर्डिनेट्स में 0.9767 minus j 0.2056 के बराबर था, प्लस what is the injected voltage or compensation voltage injected by compensator by DVR, वो भी हमने निकाली थी, वो 0.3614 plus j 0.6028. We have already calculated this DVR injected voltage. I'm just substituting the values. Okay, so therefore Vs dash will come out to be 1.3382 plus j 0.397 per unit. तो ये रेक्टेंगुलर फॉर्म में है, सो पोलर फॉर्म में है 1.3958 at an angle of 16.52 degrees per unit. अब आप देखिए, so effective source voltage is not lagging, it is leading the load voltage. तो आपकी load voltage अगर है 1 per unit, 1 at an angle of 0 degree per unit, आपकी effective source voltage है 1.3958 at an angle of 16.52 degrees per unit. So delta is positive. Delta is positive. It is positive. That means effective source voltage is still leading the load voltage, so that power flows from source to load. So you have to understand this. This is very important. Okay. So this was part C, and now we have to solve last part, part D. And in part D, you have to compute the terminal voltage with DVR compensation. Terminal voltage हो गई ये before this DVR. DVR से पहले ये जो point of common coupling है, इसको, इस पे जो वोल्टेज है उसको टर्मिनल वोल्टेज कहते हैं. Now this terminal voltage, you can see it is equal to source voltage minus this drop, source voltage minus I into RS plus J excess drop. Okay, or we can say Vt is equal to VL minus Vf. It is equal to load voltage minus this DVR injection voltage. अगर यहाँ से आप जाएंगे, so it will be source voltage minus this drop. और अगर आप यहाँ से देखेंगे, it will be load voltage minus this voltage, DVR injected voltage. So you can find it. हमारे पास load voltage है 1.0 per unit, 1.0 at an angle of 0 degree minus DVR injected voltage हमें पता है it is 0.6983 at an angle of 59.08 degrees. तो ये कैलकुलेट कर लीजिए, यहाँ से टर्मिनल वोल्टेज और वोल्टेज ऑफ पॉइंट ऑफ कॉमन कपलिंग निकलेगी, दैट इज 0.8796 at an angle of minus 43.28 degree per unit. That's all. So therefore, this numerical problem I hope will help you to a large extent to understand what we were discussing theoretically. Okay, we have over last two classes we have been discussing load voltage compensation by DVR, how DVR can compensate the load voltage, what is DVR, what is the basic structure of DVR. I told you DVR is a series connected custom power device. It through injection with the help of voltage source inverter and injection transformer, and with proper control algorithm, it injects the voltage in series with the load like this. It synthesizes the voltage source, it injects the compensation voltage, or it injects the filter voltage VF in series with the load in order to regulate the load voltage. अभी तो हम load voltage regulation ही पढ़ रहे हैं, making load voltage same as source voltage, so that this voltage drop which was making load voltage less than source voltage, this is compensated, and this DVR compensation voltage makes load voltage exactly equal to source voltage. We have been discussing this part, this function of DVR. Okay, and in today's lecture I have also discussed with you a generalized phasor diagram, a phasor diagram in absence of DVR injected voltage and in presence of DVR injected voltage. And we have seen that in order to make load voltage same as source voltage, the load voltage should be, it should touch the trajectory, circular trajectory of source voltage. For that purpose, the locus of Vf minus Ji into Xs should, touch this trajectory, circular trajectory. It may touch it at 2 points or at 1 point. And we also learned that I into Rs in the extreme case should be equal to CD. But if I into Rs is greater than CD, then DVR fails to compensate the voltage. It fails in its voltage compensation purpose. And we have also calculated what should be the feeder resistance, or how much should be the current, maximum value of current for given load power factor, in order to make CD, in order to make I into Rs less than or equal to CD, so that DVR can perfectly compensate the load voltage. And then we did some mathematical computations for calculating the injected voltage with this condition. With this condition, we calculated the injected voltage. We got a quadratic equation, something like this. And after solving the quadratic equation, we can find two values of DVR injected voltage, and smaller value we take as the solution, because smaller injected voltage means DVR power rating is less. If you take larger value of injected voltage, that will increase the rating and cost of DVR. And all these concepts were aided to us with the help of a numerical problem. We took a problem, a distribution system first without DVR compensation, calculated load current, load voltage, and we found load voltage is about 71% of the source voltage, 71% of the rated value without DVR. After connecting the DVR, we compensated the load voltage, made load voltage exactly equal to source voltage, and found the new value of load current. And we also found the injected voltage by DVR, compensation voltage Vf, using the quadratic equation. And we also found that the effective voltage is not Vs, effective source voltage, that is Vs plus Vf, and that still leads the load voltage by certain phasor angle. Power angle delta is still positive, so that power still flows from source to load. So this load regulation problem, voltage regulation problem, we have understood how a DVR does it. DVR does not do, this is not the only function that DVR takes care of. It takes care of voltage swells also. There may be an increase in the voltage, it takes care of that also. It takes care of voltage flickers also. It takes care of, it compensates the voltage unbalancing also. And it compensates voltage harmonics also. So some of those aspects we'll study in future lectures. So I advise all of you to go through this lecture and previous lecture also, and try to learn how DVR works, how it compensates, how it does the voltage compensation. So I again advise you to go through these lectures, and in case of any difficulty, any doubt, please feel free to ask me. I will be pleased to reply your all queries. Thank you.